Part A has two parts. The first is to calculate the Pearson's product moment correlation coefficient R for this data. And then the second part is to comment on the result. So let's start with part A. We want to find R, the correlation coefficient. And just to recap, the R describes the relationship between the two variables, which in this case here is the number of clients that this law office brings in and the associated revenue. Now you would expect that the more clients that the law firm brings in, the more revenue. So for every additional client, you should get more revenue. The question is, well, how closely are they linked? Is it one for one, or is it a little bit more vague? And that's what we're sort of finding out here. So let's go ahead and find out our R value using our calculator. Okay, so we go to the statistics section. I just cleared that out. Okay, I'm going to label my two columns here. So number of guests is X. The revenue brought in US dollars is Y. And now we're going to go ahead and enter all of this data. So 6, 12. So notice here that my table that I'm creating is going to be going downwards, down the columns, whereas the table that we have in the question goes across in rows. Our calculator handles data going downwards, so we just need to sort of transform this into a table going down. But that's fairly straightforward. I'm just reading off this data here, so 6, 12, 16, and just converting it downwards. Okay, I'm just going to pause the video and enter the rest of this data in. Okay, I finished the first column there, tab across to the next column, up to the top, and now I enter the associated revenue. So 3,000, 7,200, and again I'm going to pause the video now and enter the rest in. Okay, so all the data is now entered. I now go across to the top of the next available column, and I'm going to perform a linear regression stat calculation. So we go menu, number 4, statistics, number 1, stat calculations, and I'm going to choose this one here, number 3, linear regression mx plus b. The X list is the X column, the Y list is the Y column. That was the benefit of labeling our columns. Hit OK. Now we get some good information here, which will also be useful for part B, but we'll get to that a little bit later on. We are now interested in this R value here, the Pearson's product moment correlation coefficient, R. It's a bit of a mouthful to say. And rounded to 3 significant figures is 0.995. So you can see that's where I got that answer from. So that's the first part of A. The second part is to comment on the results. So let's do a quick summary of R values. So I have an R value. It'll be between 1 and -1 with 0 in the middle. Now, numbers between 0 and 1 are positive as opposed to negative. Now that actually means, in addition to sort of logically 1 is positive and -1 is negative, but for positive R values, it means that the data has a positive correlation, which means it trends upwards like this. Or in other words, as the one variable increases, the other variable also increases. So this is for positive R values. Conversely, if the data was trending downwards like this, then we would say that the data had a negative correlation, which meant that as one variable increased, the other variable decreased. So that's negative R values. So that's the sign, whether it's positive or negative, and the strength is how close to 1 or -1 it is. So if it's very close to 1, which is definitely the case for R's, it's a strong correlation. If it's between about 0.85 and 1, it's strong. If it's between about 0.5 and 0.85, it is moderate. And if it's between 0 and 0.5, it is weak. And likewise on the negative side as well. Okay, so with R's being very strong, 0.995, I can summarize that the correlation is positive, strong. It's important to have these two words in there, the strength and the sign. So positive, strong correlation between the number of clients and revenue. Part B, write down the equation of the regression line y on x. So just before we go into this solution here, let's just firstly talk about what this means. So our regression line y on x will have the form of a straight line, so y equals mx plus c, where m is our gradient and c is our constant at the end, our y-intercept. Now, in this case here, the y and the x, the y stands for the revenue, and the X stands for the number of clients. So here we have an equation that represents the revenue for a given number of clients, which is very useful because if we have an accurate line of regression equation, we can estimate, well, how much money is this law office going to bring in if we bring in a certain number of clients. Very, very useful information. What we try to find now is the M value, the gradient, and the C value, the y-intercept. Now we have actually done all the hard work for this back in part A. So if you're not sure how I got this screen, it's a linear regression stat calculation. I recommend going back and watching part A. But now we have an M value of 654. So you can see here y equals 654x. The calculator has it as mx plus b, whereas most textbooks have mx plus c. Same thing, b and the c, it's just the constant at the end. Negative 540.77, so rounded to three significant figures, will be negative 541. And there we have it. There is our line of regression equation, y on x. Part C, use the line of regression to estimate the revenue of serving 20 clients and to give an answer correct to the nearest US dollars. So looking at my data here in the table, I have 6 clients, 12 clients, 16 clients, 24 clients. So 20 clients will sit somewhere in the middle here. So looking at the associated revenue, it's going to be sort of halfway between 10,500 and 16,000. So I would hope that my answer in the end will be about sort of 13,000 or so. But to find it more accurately, I can utilize this line of regression equation, which I found in part B. And just to recap, what this equation represents is the revenue, Y, for a given number of clients, X. So to find the revenue for 20 clients, all I need to do is just substitute in my X value as 20. So that's what I have done here. I have used my calculator and I get 12,539. Correct to the nearest dollar is just simply 12,539. So I don't round this to three significant figures. Okay, that is the answer to part C. Part D, determine if the law office makes a profit when serving 6 clients on a particular month. Now keep in mind that in our table at the top here, one of our data points was in fact the revenue on 6 clients, and that was $3,000. So we don't need to use our line of regression equation to find the revenue side of this. Now we are also told that the monthly operating cost for the law office is $2,500. So that'd be things like the rent on the office, electricity, printing costs, other sort of fixed costs like that. And additionally, the cost of serving each client is $200. So that's actually the lawyer's time, the time that they spent. Obviously, you need to pay the lawyer's salary, and that per client cost is $200. So looking at the working here, we start with sort of the very generic but important formula, important equation that profit is equal to the revenue, so the money the office brings in, subtract the costs, the money that the office spends. Now the revenue on 6 clients, as I mentioned earlier, is $3,000. We get this just from the table. Subtract the costs. Now, the costs will be the fixed part of the law office cost, $2,500, plus 6 lots of the variable costs, because 6 clients are served, so 200 times 6. Put this into our calculator, we get negative 700, so that doesn't sound good. That sounds like a loss. It's a negative number. So therefore, the law office makes a loss when serving 6 clients. Part E sequences through 3 questions here. They're all good questions. It's really sort of the question here, and that's to determine how many clients are required in order for the law office to actually become profitable. But let's start at the top. Write down an expression for the total revenue of serving X clients. This is the same as our line of regression equation, the equation that we found in part B. In part B, we found this as y equals 654x subtract 541, where y is the revenue and x is the number of clients. So it's actually the same thing, but I'm just going to rename y as revenue R. So that's the first part, fairly easy start. The second part is to find an expression for the profit of the law office when serving X clients on a particular month. Okay, so let's have a look at this working here. Profit is equal to revenue subtract costs. Really important sort of equation to remember. It's very logical. Profit is the money brought in, subtract the cost that's taken out. Now the revenue expression, we just defined it as 654x subtract 541. Subtract the cost expression, which is our fixed component of the cost, 2,500, which is sort of the monthly fixed cost of the law office, plus our variable component, which is 200 times the number of clients seen, X. In this next line, I have just simply expanded out my brackets, and then to get to the final line, I have grouped like terms. So I can group my X's together. I have 654 X's here, negative 200 X's there. That gets 454. And then same for the constants, I just group these two negative numbers together to get negative 341. Okay, so that's a very useful expression here for the profit that the law office makes for a given number of clients. And we're now going to use that for the third part of E, which is to find the least number of clients required to be served to result in a profit for the month. Now, just to recap, in part D, we determined that the law office does not make a profit on 6 clients, so our number here is definitely going to be greater than 6. But let's go ahead and solve it. I'm interested in the point when profit is equal to 0. When we get to that point, every additional client after that will be a profitable client because the fixed component of the cost has been covered. So I let my profit equation equal 0, and then I solve for X, the number of clients. So let's go ahead and do that. Okay, so menu, algebra, numerical solve. It'll be 454x subtract 3041 equals 0. And then I do comma x, telling my calculator I want to solve this for x. And I get 6.69, or 6.70 actually, rounded to 3 significant figures. Now you can't have 6.70 clients. It's either going to be 6 clients or it's going to be 7 clients. Now, 6 clients will be less than 6.7, so therefore it'll still be loss-making, and we actually did determine that back in part D. So the first number of profitable clients per month will be 7. So hence, at least 7 clients are required to result in a profit for the month.